So if you want your character to look like this, or even this, welcome to the most advanced beginner-friendly Metahuman course out there. Even if you're a complete beginner, in this course you're gonna learn how to fully customize your Metahuman and give it a truly unique look by using just a Substance Painter and Blender, so no paid plugins, no extra add-ons. And as I mentioned before, this is a beginner-friendly course, so if you have never used Blender or Substance Painter, this course is for you because I'm gonna walk you through the whole step and you're gonna gain the skills to customize your Metahumans for your cinematics or your game project. Because in this course, not only are we gonna use LOD0 to create our Metahumans, but I also gonna show you how you can transfer data to the higher LODs. I also gonna go over the common issues and gonna show you how to fix them. My name is Mars Freemanist and let's jump into it. So I'm gonna start this course by creating a face scan of my face. If you want to use something else like AI generated head mesh or just use the templates from the Metahuman creator, so you can just pick up the appropriate section in the video and start from there. To follow along, you're able to use free version of the 3ds Sapphire. The only major limitation for the free version of 3ds Sapphire is you can only use up to 50 photos for your 3D scan, which in my experience honestly is plenty to get usable results. To take your photos, you can use any camera including your smartphone. If you have access to a DSLR, I recommend using it in combination with polarized camera lens, as it will remove some of the reflections and shine, therefore dramatically improving facial scan results. For custom Metahuman face, we need an ear-to-ear 180-degree face scan. For this project, I split 180 degrees into the 30-degree increments. At each designated spot, I took 5 photos, which put me at 30 photos. I would like to say it is a minimum amount. You can split 180 degrees into the even smaller increments to get more photos for your scan. More increments will help you achieve an even more accurate scan. One important tip that is a game changer is to turn on grid on your camera, as it will help you frame your photos. Maintaining as constant framing as possible for each set of photos will help your final scan look as clean and accurate as possible. In an ideal world, we would have 50 cameras that are positioned at the same distance and same angle and take photos at the exact same time. But as most of us don't have access to the professional face scan studio, this is one way to try to get close enough to that effect. Important fact, after you're done taking your photos and importing them into your computer, do not modify them in any way. Any color grading and especially cropping will lead to an inaccurate photo calibration later, and photos will be unusable. Once you have taken your photos, you're ready to import them into the 3ds Sapphire. To do this, go to Workflow, New Project. Select Model and Texture and press Next. Press the plus icon and while holding Shift, select the first and the last photo. Then press Open and press Next. Here we can see all imported photos. Sapphire has recognized my camera and calibrated the settings accordingly. Now we can press Next. In Category, choose Human Body. Presets can be left as default for now. Press Next. Same setting here. In Category, choose Human Body. You can leave presets as default. Press Next. Once again, in Category, Human Body, Presets Default. Press Next. In Texturing Presets, in Category, choose General. In Presets, Default Single Texture. Press Next. Now press Run. When reconstruction is done, a new window will appear that will let you know how many photos are usable for reconstruction. It is acceptable if few photos are not usable for reconstruction, but if you get a lot of no's, then you need to redo your photos and try again. In my case, all photos were used for reconstruction, which is the ideal situation. After we press Finish, we can see our model in the 3D space. Now we need to crop out our face and get rid of any unnecessary reconstructed detail, which is very easy to do. Let's click on Bounding Box Editor. Now we can see bounding box in our scene. This will help us to isolate our face from the rest of the scene. By moving the dots, you can shrink the box. By clicking Rotate in the Control menu, you can rotate the box. Remember, we just need 180-degree scan of our face, so we can crop some of the head detail in the back. Adjust the box to the face as close as possible. Once you're done with the bounding box, it's time to remove any unnecessary mesh. Go to Workflow, Advanced and Mesh Extraction. Make sure all cameras is selected and press Next. Press Next. Once mesh creation is successful, you can press Finish. Now we are ready to export. Go to Export, Export Textured Mesh. The parameters that we need to change are Export Format, OBJ. Rescale texture to 8K. Now we can press export. Now we can import our mesh into the Blender. Go to File, Import, OBJ. We need to rotate our mesh to face the right direction. Adjust your camera to face -Y. Then adjust mesh to rotate using rotation parameters. Our mesh has unnecessary geometry that can interfere with the face creation in Unreal. Let's remove it. Go to Edit Mode, select Lasso tool. Switch to Side View, switch to Wireframe, and remove any detail behind the ear. We can also remove shoulder part as we only need the neck for our mesh. Once you are done with selection, press Delete Vertices. At this point, you can either export your mesh or do some mesh smoothing. This is something you will need to experiment on your own with much or even if all smoothing will improve Metahuman face quality. You can export both meshes and compare them. In my case, I will choose to do quick mesh smoothing using sculpting tools. Using smooth brush at low strength, I will smooth all the bumps in my mesh. Here it's important not to overdo, because it can lead to losing important details. I recommend using scrape brush to flatten hair to match head shape. Otherwise, during the Metahuman face generation process, Unreal will treat it as a part of the head shape and your head will look bigger than it is. Once you're done with your mesh, export it as OBJ. Now once our face scan is done, we are ready to move to the next step where we're gonna retopologize our mesh using Mesh to Metahuman. First, make sure that you have installed Metahuman plugin from Unreal Engine Marketplace. Just click Install and choose the engine that you want to use. For this project, I recommend to use Unreal Engine 5.4 or the newer version. Next, we need to enable the Metahuman plugin. Go to Edit, Plugins, and search for Metahuman. Enable plugin, click Yes, and restore the engine. To keep things organized, I will create a new folder. Now let's import the mesh that we created in the Blender. In my case, imported mesh is rotated incorrectly. If I put it in the scene, I can see that I need to rotate it for 90 degrees on the X-axis. So I'm gonna make a right click and choose Reimport. Into the window, I will set rotation to 90 and click Import. Now in the thumbnail we can see that the mesh has correct rotation. I will delete automatically created material and I will import the texture from the 3ds Sapphire. Before you're importing, make sure that the mesh that's in your scene and the texture names are different. In Unreal Engine 5.4, now you can't import files with the same name even if they are different file types. Now I will create material from the texture and I'm just gonna apply the material to the mesh. Now before we are moving forward, we need to enter the console command. You can do it either here or output log. You can find output log under the Windows output log. So the command that we need to import is mh.identity.export meshes and we need to set it to true. We can see in the window that we have successfully changed the parameter to the true. Now we're gonna make a right click, go to Metahuman Animator, and choose Metahuman Identity. Identity you can set up any name you want because we're not going to use this to create our Metahuman. We're going to use this identity only to create our new mesh. So I'm just going to call mine face mesh. Open it up. The login window going to prompt, so if it's necessary, log into your account. Now what we're going to do, we're going to go create components from mesh, Facescan. So once you have imported your mesh, you can move the camera. Here you can also play with the modes. Usually for the scans, unlit works the best for me. So adjust your camera so it's close to your face. Then let's click the body and set your body type. In my case, I will set tall, normal body. Now click back to the face and click promote frame. I'm gonna move it a bit closer. Now I will make a right click, auto tracking. So after auto tracking is done, we're gonna make another click and click lock camera. So in this step you can add more tracking points if you want, but for this tutorial I'm just gonna keep the default ones and you're gonna see that actually the results are pretty fine. So I'm gonna click Metahuman Identity Solve. So after it's done, we can set the free camera and check how our new generated mesh looks like. And if I look closely, it actually has done a really good job tracking my face details. And even so, I didn't track the ears. It actually has tracked my ears pretty well, pretty accurately, even without ear trackers. So now what we're gonna do is, we're not gonna create a Metahuman in this step. We're gonna close this for now. Now make a right click on any of the files here and choose Show in Explorer. It's going to open up your project, and let's go back to the root of your project. So in my case, it's called UE5 Metahuman Tutorial. Open Saved and find a folder that has the same name as your Metahuman identity that you just created. Open it up. And here we have a quad mesh of our face. Now open up sculpting software of your choice. In my case, I will use a Blender. I will go File, Import, OBJ. If your head mesh doesn't look really like your scan, what you can do is, so go to the modifiers, click Add Modifiers and search for Normal, Weighted Normal. And we can just apply it, and now we can see our mesh looks like a scan. So in this step, we can add sculpted changes to our face mesh. So we can go here. Be aware that in areas like eyes or mouth or ears, you need to experiment how much changes you can make. But for the rest of the face, you can go actually pretty crazy. So I'm just gonna add symmetry, and you can start to make different kind of face adjustments if you want for your character. So in my case, I will not use this mesh, but you can use it for your project. And if you want to make some face adjustments, this is the step where you're gonna do it. You can see we can actually get pretty crazy results straight in a Metahuman creator, and actually not a lot of people know that you can actually get this kind of weird faces straight in a Metahuman creator without any kind of like softwares. After you're done editing your face mesh, you can just go File, Export, and OBJ. So after you are done editing your mesh, we can create a new folder here and call it Edited Mesh. Open it up. So if you choose to modify your mesh, then you're going to import your edited mesh. In my case, I will not do that. Then I will just import the one that it's in the face mesh folder and save as face mesh folder. Reset rotation to 000 and click import. It's okay that your face mesh is rotated incorrectly. That really doesn't matter. So now what we're going to do, we're going to create a new Metahuman identity again. Here you give your Metahuman name, because now we're going to create our Metahuman that we're going to later edit in Metahuman editor. I will call it mine Cyber Viking. Open it up, and now instead of going to create components, we're going to go to Assets, Configure Components, and find a new mesh. The reason we are doing this is this mesh right here going to be way closer to your actual scan and give way better results if we would use just this one and create Metahuman right here. So here all we need to do is just go to the body, set up the body type again. So again, I'm going to set tall and normal weight, and we're just going to go here, mesh to Metahuman, sculpt on mesh for full Metahuman. We don't need to track face again or anything like that. So Unreal Engine, I'm going to use this mesh to create your Metahuman. Now we are ready to move to mesh to Metahuman, where we're gonna bring our head mesh to life. Well, I'll be using Metahuman with the custom face mesh. The same customization steps also apply to the template meshes, if you choose to use any pre-made mesh as your base mesh. Here you can change your Metahuman project name if you don't like the name you gave during the identity step. Before I make any facial adjustments, I usually like to apply the skin first. You can adjust your skin color and choose different textures by moving the slider. The slider is a bit confusing since you are choosing different textures by moving it instead of blending textures. Go through all the options and choose the closest one that fits your skin. After that, you can go to blend section and improve any facial detail that have not translated during your face mesh generation. One great option here is that you can mix your face mesh with a parent mesh by choosing at least 3 parent meshes. The benefit to this is you can choose parent meshes with the features that resemble the look you're going for. Then you can mix them together to tweak your face as you like. This step can take a while, but it can help you truly to get the look you want. I would suggest first adjust eye color, eyebrows, hair, and facial hair if you have one, and then revisit the blend tool again. Doing this will give you a better understanding of what is still needed to be tweaked once other details are in place. You can also adjust the body proportions in case if you want to change body size or body type. One important setting here is a head scale. As changing the body size and type, you generate a head size can either be too small or too big. To get the size right, I would suggest you to take a screenshot of your character and compare your body proportions to this photo. This will help you to get a better idea of how you need to scale your head comparing to the rest of the body. One last thing we need to make sure is that top and bottom are set to none and shoes are set to flip-flops. Once you're done adjusting your mesh, you can go back and close MetahumanCreator. So now once we have added all the data to our Metahuman, now we can import it in our Unreal Engine project. Press Window, Quixel Bridge. In the bridge window, on the left side click Metahuman. Then My Metahumans. Find your custom Metahuman and click on it. Make sure it's set to the highest quality and then press download. After the download is complete, once again double check quality and then press add. Missing plugins and setting window will pop up. Enable all three of them by clicking enable missing on each. Restore engine will pop up. Restore the project. Our custom Metahuman BaseMesh is ready. In this section we will export our BaseMesh and prepare our Blender project for more sculpting. Using Blender, we will sculpt new detail to our Metahuman character to give him a unique look that fits our project. For this, you will need to download FBX Converter from Autodesk. This software is available for free and doesn't require you to have Autodesk account to download. FBX Converter is needed to keep shape keys when your mesh will be imported into Blender. If we import mesh straight into the Blender, the mesh will miss shape keys that are used to give facial expressions to the face. In your project, go to Metahuman folder, then choose Base Metahuman folder. We will need to export head and body meshes. In folder, select your body characteristics, in my case, male, tall, normal weight, body. Then make a right click, go Asset Actions, Export. In Export window, press Reset to Default and then Export. Then we can go back to the base folder and open Face folder. Scroll down and find Face Mesh. Then make a right click, go Asset Actions, Export. In Export menu, press Reset to Default and then Export. Next, open FBX Converter and drag both FBX files into the source file window. Then press Convert. You should see Converted for both meshes. In folder where you had FBX files, Converter has created new folder FBX 2013 with converted meshes. You can delete old ones. Now we can import both converted FBX files into the Blender. In Scene Collection we can see face and body files that consist of LOD groups, skeleton and multiple LODs. For this we will need only LOD 0 for the face and the body, so we can delete the rest. When you delete LOD groups, your character will resize, which is normal. At the end, you need to have only LOD 0 face and LOD 0 body mesh. To make it easier to see sculpted details, in Material Properties, I will change Viewport Display Color to something brighter. Then click on Face Mesh and go to Object Data Properties. Under the Shape keys, click down arrow and choose Delete All Shape Keys. When Metahuman is exported from Unreal Engine, it consists of multiple parts that makes it hard to work with. We will join all the body parts and some face parts together. Select Body, go to Edit Mode. Make sure you have clear selection. Then go to Select, All by Traits, Non-Manifold. Then go to Mesh, Cleanup, March by Distance. Now we will join some of the face parts. Select Face Mesh and go to Edit Mode. Make sure you have clear selection. Then go to Select, All by Traits, Non-Manifold. Switch to Side View and turn on Wireframe View. And deselect Eyes and Mouth. Then go to Mesh, Cleanup, March by Distance. Now we can go back to Object Mode. Now select face and body parts, press Ctrl J to join them together. As before, to see our details, go to the modifier, click Add the modifier, search for Normal, and add a weighted normal modifier. Then click Apply. Now we are finally at the sculpting part. Usually for my sculpting, I like to find the references, and I think one of the great places is ArtStation, where if you search for anatomy, you can find really great references there for your sculpting. If you want to do sculpting in other software like ZBrush, just export mesh, sculpt your mesh without changing vertex order and vertex amount, and then re-import it back into the Blender. Now we can switch from object mode to sculpt mode. On the left side, you can see multiple brushes. Well, you are free to try any of them and see which helps you bring your desired details. For the most part, I use only 4 brushes: Draw, Draw Sharp, Crease, and Smooth brushes. By adjusting the radius and strength, they will be enough for the most operations. Metahuman BaseMesh is already full of great muscle detail. I've liked my character just to have a bit of a beefier look. With the draw brush, I will just go over every muscle to bring out more detail. While sculpting, don't be afraid that it looks a bit bumpy at first. With the smooth brush, you can even it out. My Metahuman sculpting usually follows the same pattern. With the draw brush, I bring out detail. With the smooth brush, I even out bumps and get rid of sharp edges. And at the end, I go over with the crease brush to bring out muscle detail and make separations where something has sculpted together during the sculpting process. The only thing you need to keep in mind is the skeletal mesh bone locations. During the sculpting process, body parts need to stay in the same location as they were before. Otherwise, it will create issues later when playing animations. I also would highly suggest avoid any sculpting for the face, since facial expressions are controlled with a lot of bones. Sculpting the face can easily mess with the bone locations that will give face animations issues later. If you need to make major face changes, then I suggest making necessary changes to the face, exporting only the face mesh, and then you can use the mesh as a starter mesh to create a new Metahuman from Identity. Even though this will make you need to redo the whole process once again, it will help you prevent any animation issues for your Metahuman face later on. Before exporting our morphed LowPoly Metahuman mesh, we need to make a fix that can make visual gaps later when the model will be imported into Unreal Engine. To do this, go to Edit mode and make sure you are in the vertex selection mode. Turn on Magnetic Snap and in Snap select Vertex. Now while following along the line where the head and body met, you can see this line is a bit darker than the rest of the lines. We will snap the points together. Select the body center point, then press G. Move it a bit away to make sure you have selected the point that connects both meshes and snap it to the head center point. Now we need to repeat the same process around the whole body. Deselect everything and then select any point on the body. Go to Select, select Linked, Linked. While the body part is selected, press P and choose Selection. Now we can switch back to Object mode. To make project nice and clean, I can rename both meshes. For the next step, we will import again converted face and body FBX files. Let's move converted meshes to the new collection. Select both mesh groups, make a right click and choose Move to Collection, New Collection. Since I like to export LODs separately, I will delete LOD groups. You should have root as a parent for face and the body. Now we can unhide morphed meshes and move them to the side. I will hide the skeleton for now. We will start with LOD 0. Open root groups and hide other LODs. To be able to transfer morphs to the LOD mesh, we need to have the same vertex count as morphed mesh. Let's march non-manifold edges the same way we did before with morphed mesh. Now select Morph Head Mesh. Then while holding Shift, select LOD0 Head Mesh. Then under Shape Keys, click down arrow and choose Join as Shapes. New shape key will be at the bottom of the list. I will rename mine to Morph. Then we will do the same thing for the body. Select Morph Body. Then while holding Shift, select LOD0 Body Mesh. Then under Shape Keys, click down arrow and choose Join as Shapes. New shape key will be at the bottom of the list. I will rename mine to Morph. Now depending if you want to use other LODs, you can either export LOD0 only for your project or follow along the next steps where you will transfer more details to other LODs. Since higher LODs are simpler version of LOD 0, they have different vertex count. Because of that, transfer shape keys will not work. Instead, we need to use Mesh Deform modifier that will approximate vertex changes. To automate this process, we will use ShapeKey Wrap plugin that's available for free. Once you download the plugin, go to Edit, Preferences, then go Add-ons, Install. Select Add-on and click Install Add-on. Give a few seconds for plugin to install, then enable it. You can find installed plugin in your end panel. Now before we are transferring shape keys, we need to join non-manifold edges for the rest of the LODs the same way as we did before. Now let's start with the body. Unhide all body LODs, then select LOD 0. While holding Shift, select the rest of the LODs. Then in Add-on window, click Transfer by the list. Then click Refresh. Select Morph Shape Keys. Then click Transfer Shape Keys. Now if we unhide any of higher LODs and move LOD 0 Morph slider, we can see morph changes. You will not see any changes if you will move slider in other LODs, since they are only links to the LOD 0 shape key. Now let's do the same thing for a face mesh. Unhide all face LODs, then select LOD 0, while holding Shift select rest of the LODs. Then in Add-on window, click Transfer by the list. Then click Refresh. For face mesh, list will be full with the shape keys that are responsible for facial expressions. We don't want to override that data. To make sure nothing is selected, click Uncheck All. Then select your Morph shape key at the bottom of the list. Then click Transfer Shape Keys. Now if we unhide any of higher LODs and move LOD 0 Morph slider, we can see morph changes. You will not see any changes if you will move slider in other LODs, since they are only links to the LOD 0 shape key. Now in Object Properties, we need to rescale both skeletons from 1 to 1.01. Now we can export our meshes. I will start with the body. As I mentioned before, I will export each LOD separately to make sure that LOD order is correct later when we will import meshes in Unreal Engine. If you export LODs as a group, Unreal Engine will organize LODs by their creation order and not by the name. Name is irrelevant in LOD creation process and works only as a reference for you as an artist. Since our mesh is imported, there is no guarantee that LODs at the backend are in order they should be. I always prefer to export them separately and then import them in Unreal at the right order. Make sure that the skeleton name is root without any number. Select skeleton and then while holding Shift, select the body mesh. Go to File, Export, FBX. In Export menu, select Selected Object, Object Type, Armature and Mesh. Under Geometry, select Smoothing to the face, and deselect Apply Modifiers. Then under Armature, deselect Add Leaf Bones and deselect Bake Animations. Then click Export. Now repeat the same process for the rest of the LODs. Now rename face skeleton from root 001 to root. Now select skeleton and a face mesh. Go to File, Export, FBX. Give your face mesh a name. Double check if the settings are correct and then click Export. Now repeat the same process for the rest of the LODs. After we are done with our exports, we can import the face and the body mesh into Unreal Engine. Create a CyberViking folder. Then, to keep things organized, create a folder for the face and the body. Then in these folders, make a copy of original Metahuman face and the body meshes. We can use these meshes to re-import our modified Metahuman meshes. We will start with the face mesh. Open it up. Before we import our new mesh, we need to make few changes in asset details. First, search for source. In source path, set converted face mesh from FBX 2013 folder. Then make sure that import more targets is enabled. Then scroll down and find transform section. Change X rotation from -90 to 0. Then under reimport base mesh, choose reimport base mesh plus LODs with new file. First select LOD0 face mesh. At some point, a new window will appear that will inform you about material conflicts. This is very easy to fix. The current asset material list follows the same order as reimport asset materials. Let's start with the first one, Shade Head Shader. If you right click on MI Head Synthesize Bake, in drop down choose Shader Head Shader. Now retarget the rest of the materials in the same manner. After you have done this, press Done. Then, as stated on top of the window, we need to import LOD1. Now keep selecting the rest of the LODs. Now if we close our mesh and reopen it, we can find our morph target at the bottom of the list. As we can see, our morph works inside Unreal Engine. We can also see changes if we switch to other LODs. If we switch to animation menu and select our new face mesh as a preview mesh, we can test if our mesh has been imported correctly and nothing is broken. We can confirm the animation is playing correctly. Now we can repeat the process for the body mesh. As before, we need to make few changes in asset details. First, search for source. In source path, set converted body mesh from FBX 2013 folder. Enable import morph targets. Then scroll down and find transform section. Make sure that rotations are set to 0. Then under reimport base mesh, choose reimport base mesh plus LODs with new file. First select LOD0 body mesh. At some point, material conflict window will appear. Fix it the same way as you did for the face. Then as stated on top of the window, we need to import LOD1. Now keep selecting the rest of the LODs. Now if we close our mesh and reopen it, we can find our morph target in morph target list. As we can see, our morph target work inside Unreal Engine. We can also see changes if we switch to other LODs. Now let's copy Metahuman blueprint to CyberViking folder. Open it up. Now we need to create blueprint logic that activates our morph targets. Make a right click and search for custom event. Give it a name, set morph targets. Now drag the body and face variables into the event graph. Now grab a pin from the body and search for set morph target. Set morph target as morph target name. Set value to 1. Make a copy of it and connect face as a target. Now we will activate our custom event. Go to construction script, At the beginning of the chain, grab a pin for the construction script and search for Set Morph Targets. Now our mesh will use morph targets we created. Then go to Viewport and select Body. Change the Body Skeletal Mesh to Cyber Viking Body Mesh. Then go to Face and change the Face Mesh to Cyber Viking Face Mesh. The hair system is binded to the skeletal mesh. So as we change the skeletal mesh for our character, this binding has broken and our hair is all over the place. There's an easy way to fix this, as each component that consists of a hair particle, such as hair, beard, or eyelashes, has a grooming asset and a binding asset. We need to make new binding assets to fix the broken hair particles. Let's create a folder called Hair. Go back to Blueprint and we will start with eyelashes. Find the eyelash grooming asset, then right-click on the asset and choose Create Binding. Find your Cyber Viking Face Mesh as Target Skeletal Mesh. Now you can move the new binding asset in the male hair folder and click on the new asset so it's highlighted. After that, go back to Blueprint and switch the old binding asset for the new one by pressing the side arrow. Now repeat the same steps for the rest of the grooming assets. When you are done, close and reopen Blueprint. And our grooming assets are fixed. Now I will drag my character into the scene and we will test facial animations using the live link. Excellent! Everything works how it should, and if we test our character using the sequencer, we can also see that the body and the face work as intended. Congratulations, I think we are halfway there. Now we're gonna get back to the Blender where we're gonna work on our low-poly and high-poly meshes that we will later use to bake high-level details for our low-poly mesh inside Substance Painter. Open up your Blender project. Duplicate your morphed mesh collection. Rename collection to low-poly. Select Mesh and go to Edit mode. Then under Material Properties, find Head Synthesized Baked Material and click Select. Then go to Select, Invert. Press Delete, Faces. Now in Object Mode, select Head and Body Meshes and press Ctrl J to join them together. Then switch to Edit mode. Make sure you are in a vertex selection. Then go to Select, All by Traits, Non-Manifold. Then go to Mesh, Cleanup, March by Distance. Now go back to Object mode. Then go to Material Properties and leave only one material into the list. I will rename my mesh to low-poly mesh. Now you can duplicate low-poly collection and rename it to the high-poly mesh. I will hide low-poly collection for now. Select HighPoly mesh and go to Sculpt mode. As before, to see our details, go to the modifier, click Add the modifier, search for Normal, and add a weighted normal modifier. Then, click Apply. As our HighPoly mesh will be used for detail baking only, here we don't need to worry about poly count. That gives us freedom to use tools like DynTopo that will add extra polygons during the sculpting process. Tools like DynTopo opens possibilities to use smaller brush radiuses to add fine details like veins. I will speed through my sculpting process because once again there is no right or wrong way to do it. It all comes down to the creative choices. So you can customize yours whichever way inspires you. The only thing that you need to keep in mind is that the high-poly mesh needs to overlap with the low-poly mesh for the clean baking results. It's all about the detail here. For the high-poly mesh, you are allowed to use sculpting tools also for the face to add other attributes such as scars or cyber details, as now it will not interfere with the skeletal bones. Don't forget to use reference photos to get more realistic end results. and have a fun experimenting. Now we are finally ready to get all our meshes into the Substance Painter, where we're gonna do the texture painting, and I'm gonna go over all the basics. So if you're a complete beginner and have never used Substance Painter before, then I'm gonna go briefly over every detail that you would need to know to start your own custom metahumans in the Substance Painter. Metahuman head and body are separated in different UV tiles. It helps to achieve higher quality textures without increasing the texture resolution. Since we have two different UV tiles to work with, we're gonna use UDIM workflow inside Substance Painter. Let's start by exporting our low and high poly meshes. Select low poly mesh, go to File, Export, FBX. Select Limit to Selected Objects, Object Type Mesh, deselect Bake Animations, and add Leaf Bones. Then press Export. Now export our high poly mesh. Select High Poly Mesh, go to File, Export, FBX. Rename mesh to High Poly, then press Export. Then we will need to open our Unreal Engine project. Find Metahuman Blueprint and open it up. Select Body, and open up the body material. First, let's find our base color texture and export it. You can export all the textures in any format you want. I usually love to work with TGA formats, but you can export it in PNG as well, or even JPEG if you want to save some space. Then in the same material, find the normal map and export it. Then from the same folder, export body roughness. Then we can go back to the blueprint and do the same thing for the face mesh. Find the face material and open it up. Scroll down and find the base color. Export face color main and also face color CM1, CM2 and CM3. CM and WM textures are used for wrinkles. Then go back to material and find normal textures. Export face normal main, WM1, WM2 and WM3. Then go back to material and find face roughness main and export it. Now let's create a new project in Substance Painter. Press File, New. In the new window for the template, choose Unreal Engine 4. Then select Low Poly Mesh. Change the document resolution to 4K and make sure that Use UV Tile workflow is enabled. Now our mesh is successfully imported into the scene. Next, we need to import the texture files that we exported from the Unreal Engine. Select all the texture files and drag and drop them in Substance Painter. While holding Shift, select all the textures and change the prefix to Base Textures, and change object type from undefined to texture. Now we will set up our skin layer. Create a new folder and call it base material. Then inside base material folder, create face and body folders. Now we will assign each folder to its own UDIM tile. Click on dotted square and deselect 1002 for face folder and deselect 1001 for body folder. Now we will apply textures. Find face color main and drag and drop it to the character. In pop-up window, choose base color. Change projection to fill and put it in face folder. Now do the same thing for the body base color. Now find face normal main and drag and drop it to the character. In pop-up window, choose normal, put it in the face folder and change projection to fill. Now do the same thing for body base normal. Next, find face roughness main and drag and drop it into the character. In the pop-up window, choose roughness. Change projection to fill and put it in the face folder. Now make a right click on face roughness layer and choose Add Generator. Deselect everything except roughness. Then in Generator, search for grayscale conversion. Change grayscale type to red channel and set invert to true. Also deselect everything except roughness. We are choosing red channel because Metahuman roughness texture has two roughness textures, each stored in different channels. In red channel is baked roughness texture, but in green channel you can find a roughness that is made from normal map through texture compositing. We can see that both of these channels are used in the master material, so we will keep the same setup for our Metahuman. Now do the same thing for a body roughness. The last thing to do before we are jumping into the texturing is we need to bake HighPoly details to our LowPoly mesh. In Texture, Set Setting panel, scroll down to the bottom. In Mesh Maps, press Bake Mesh Maps. On the left side, uncheck ID and Positions since we don't need them. Under High Detail Definition Mesh, find HighPoly Mesh. For output size, select 8K. Now we need to adjust our max frontal and max real distance values. These values depend on the mesh size and the details that you have sculpted. You will need to experiment with the values to see what works best for your mesh. If the value is too low, some of the details can be missing. If the value is too big, you can get baking overlap. One of the most common places for that is behind ears. A good starting point for your values would be 0.005 for the frontal distance and 0.006 for rear distance. Now press Bake Selected Textures. If you still experience baking issues, you can also create custom cage for cleaner baking results. Open your Blender project and duplicate your LowPoly mesh. Rename it to cage, then go to Edit mode. Select all vertices and press Alt+S. Now we can inflate our mesh. Use low number like 0.1, then go back to Object mode and export mesh. Then in Substance Painter, enable Use Cage and find Cage file. We have few red areas that needs to be fixed. We can go back to Blender, select Cage Mesh and switch to the Sculpt mode. Enable Symmetry and select Draw Brush. Now go over red areas. Then go back to Object mode and export Mesh again. Repeat sculpting process until you have fixed all red areas. Then click Bake Selected Textures. Now we have got clean baking results, even behind ears and between fingers. So now our mesh is ready for texturing and it's time to make our Metahuman truly unique. I will use starter assets that are available to everyone to give Metahuman Cyber Viking look. Well, I will go over the basics before I leave you with a time-lapse of my texturing. If this is your first time using Substance Painter, I strongly recommend you watch some Substance Painter beginner videos to give you a slightly better foundation for how to use this incredible software. Beginning by opening the starter asset folder. Here in the asset window, we have multiple selections. Materials. Smart Materials is just a fancy name for the material group with adjusted parameters. Smart Materials are a great option for anyone just starting out, and eventually you will start to make your own smart materials. Next we have Smart Masks, Filters, Brushes, Alphas, Textures, and Environment. Let's start with the face. Create a new folder and give it the name Face. Then make a folder inside and call it Face Detail. Let's add fill layer. The fill layer now covers the whole body, which is not something we want. So let's right click on the face detail folder and choose Add Black Mask. Now we have ability to paint wherever specifically we want to use our fill layer. Next, let's go to the brushes and look for Basic Hard Brush. Double click it. Then in the fill layer, I will leave only the color and the height for now. Now go back to the face detail folder, right click on mask and at the bottom choose Add Paint. Now, similar how it is in Photoshop, we can use black and white colors for masking. Scroll down and make grayscale white to be able to paint the mask. Change the brush size to something small, like 0.2. For this I will turn on symmetry and can just start painting. Adjust the height to make it look like the metal is inside the skin. Now go to Smart Materials, grab Chrome Smart Material and drag and drop it into the face detail folder. When you open Chrome Smart Material in the layer list, click on the base material. And in the properties we can adjust the height there as well. So if your Smart Material lets you adjust the height, because not all of them do, then you don't need the previous fill layer and you can delete it. Now we need to get rid of our skin normal that is showing through our painted metal part. Let's switch from the base color to normal. Then for the face layer, we will change blend mode from normal detail to normal. And now face normal is not mixing with our metal part. In the same way, we can now paint other cyber details for our head. Let's go back to the smart material, find Iron Forge Old and drag it into the head detail layer. Same as before, we will add black masks so we can paint wherever we want the material to be visible. Add paint and make sure grayscale is set to white. To draw a straight line, click wherever you want the line to start, then press Shift and the line guide will appear. Then just click wherever you want the line to end. If you need to remove the detail, just change the grayscale from white to black and paint it over to mask it out. Again, you can open Smart Material, find the base paint, and paint with the height to make it look like it's on top of the skin. As you can see, there are a lot of things that are not needed to be modeled in 3D software. You can make realistic details by just painting them and adding the height. One important cyber parameter is disabled by default, and this is emissive color. Emissive color is basically that neon glow you can see, for example, in Cyberpunk, if you will. So we will add some emissive detail. Let's find a smart material that would fit. For this, I will use Glass Visor. Add a black mask to it and add a paint. Then we will use Alpha texture to get some interesting painting patterns. In Paint Mask, find Alpha. Then in Alpha section, let's find an Alpha texture that looks like small lights. I will use circle dots. Just double click them and they will get automatically assigned to the Alpha slot. Now we can paint them on the top of our metal parts. As symmetry is still on, we have the same detail on the both sides of the head. In the texture set setting, find the channel option. Click the plus sign and add emissive channel. If after enabling emissive channel, your whole body is glowing, then find your body roughness texture, click on grayscale converter and deselect emissive channel. Now do the same thing for a face roughness. Now we have extra parameter in our material list. I will copy color code from the base color and copy it as emissive color. In the Substance Painter, it's hard to see the emissive effect, but we will be able to change the brightness and even the color inside Unreal Engine. I want my Cyber Viking to have a robotic arm, which will require me to paint a bit bigger surface. You could paint straight on the arm, but also you can use a 2D window, which in some cases makes things easier to paint, especially when you need to paint bigger parts. Now I will time-lapse through the rest of the video, which follows the same workflow. Use smart materials, use masks, and paint out the details you need. While you can paint material straight on top using a paint layer instead of a fill layer, I find this way I've shown you gives more control and makes it easier to change things if needed. To add interesting paint shapes, use alpha brushes.
So once you're done with all the fun and your character is fully textured, now it's finally time to export textures. This part is probably the most tiresome part in the whole Metahuman creation process, and just put extra attention to the texture exporting process.
We will start by creating output template. Go to File, Export Textures. Then click Output Templates. In Preset list, find Unreal Engine 4 preset. Make a right click and duplicate. I will name my preset Metahuman Export. Remove Roughness Metallic Output Map. I will change all output formats to TGA. Then create a new RGB map. Find the roughness and drag and drop it to the red channel. In a pop-up window, choose Gray Channel. I will copy name from Emissive Map and change my name from Emissive to Roughness. Now create a gray map.
find a metallic and drag and drop it. In the pop-up window, choose Gray Channel. I will copy name from emissive map and change it to metallic. For optimization purposes and at the same time to get Metahuman as detailed as possible, Metahumans use different resolution texture sets. I will use these texture sizes, but you are free to use any texture resolution you want. Depending from your project, you can cut these numbers by half or even export all textures in same resolution. So I can need to export all my textures at 2K, 4K and 8K resolutions. Now click on Output directory and find a place where you want to export your textures. Create a new folder called Base. Then in this folder create 2K, 4K and 8K folders. I will start with 2K textures. As output template, select template that you just created. Change file type to Targa and set texture size to 2K. Then click Export. Now we can go back and repeat the same process for 4K and 8K textures. Now we need to export few other textures. Remember when I told you Metahumans are using 3 different wrinkle textures for the face wrinkles? It means we will need to export 6 more texture sets, 3 for each resolution. If we would skip this step, you would see your facial animations without having any wrinkles. Fortunately, we already prepared our layer setup in Substance Painter to make this step as easy as possible. Select Face Base Color, then in the Base Texture folder find Face Color CM1. Drag and drop it as a base color to replace Base Color Main. Then select Face Normal, find Face Normal WM1 and drag and drop it into the normal slot. Then go to File, Export Textures. Open your texture folder and create a new folder. Call it Wrinkles. Then in Wrinkles folder create a new folder and call it CM1. In CM folder create 2K and 8K folders. Then you can duplicate CM1 folder twice and rename duplicates to CM2 and CM3. Then go back to Substance Painter and click on Output directory and find CM1 2K folder. Set texture size to 2K and export. Then find 8K folder. Change texture size to 8K and export. Now repeat the same process for other 2 wrinkle sets. Now I will clean up textures and rename them. I will start with the base textures. In 2K folder I need to keep face base color, metallic and emissive. At the end of each texture name you can see its UDIM number. As a reminder, 1001 is face texture and 1002 is body texture. When renaming textures, make sure to remove these numbers. Otherwise Unreal Engine will import them as a virtual textures that will not work with the current Metahuman material setup. I will start by deleting unused textures. Then I will rename base color texture to Cyber Viking Face Base Color. Now I can rename emissive to Cyber Viking Face Emissive and then rename metallic to Cyber Viking Face Metallic. As I have done here, I suggest you to make some kind of list of needed textures, so you can keep track what needs to be deleted and what needs to be renamed. You can find this image in the course asset folder. Next, in the 4K folder, we can see we need to keep 4K face roughness texture, 4K body base color, metallic and emissive textures. In same manner as before, I will delete not needed textures and will rename needed textures.
Then lastly, in 8K folder, we can see we need to keep 8K face normal texture, 8K body normal texture, and 8K body roughness texture. And again, rename textures and delete not needed textures. Then we can move on with the wrinkle textures. Wrinkle textures are easier since we only need 2K face base color and 8K normal texture. I will name my base color Cyber Vikings Face CM1. I will name my normal texture Cyber Viking Face WM1. Now we will import textures into our project. Let's start by creating texture folder in our Cyber Viking folder. I will also make material folder. Now in texture export folder, in the search I will write *.tg and it will show all textures. While holding shift we'll select them all and drag and drop it into the texture folder. Now we will add green composite channel to our roughness textures. Open body roughness texture and scroll to the bottom. Set your body normal texture as a composite texture. Then change composite texture mode to add normal roughness to green. Now we will do the same thing for the face roughness. Open it up and scroll to the bottom. Set your face normal texture as a composite texture. Then change composite texture mode to add normal roughness to green. Now textures are ready and we can set up our material hierarchy. In material folder I will make folder for the face and the body. Open your base Metahuman blueprint, then go to body and find body material. Now copy that material to your body material folder. Rename it and open it up. Now scroll down until you find this material, parent material. Again, find it and copy it to your body material folder. Now replace parent material with the material that you just copied. Now open that parent material, scroll down till you find its parent material. Again, find it and copy it. Rename it and replace the parent. Open it up. And now we see we have a copy of body master material. Now we will do the same thing for a face material. Go to your base Metahuman blueprint, go to face and find face material. Now copy that material to your face material folder. Rename it and open it up. Now scroll down until you find this material parent material. Again, find it and copy it to your face material folder. Now replace the parent material with the material that you just copied. Now open that parent material. Scroll down till you find its parent material. Again, find it and copy it. Rename it and replace the parent. Now open it up and we can see we have a copy of face master material. We will make adjustments in face and body master materials. We will start with the body master material. Let's move this a bit so we can have more space. We can delete this pin since we will not use it. Make a right click and search for texture sample. Make a right click and choose convert to parameter. Call it metallic main. Now in the side panel, we will set default texture to default texture linear color. Now while holding the number 1 key, make a click. Again, convert this object to parameter and name it metallic intensity. Now hold M key and make a click to create a multiply node. Connect intensity to A and texture to B. Connect end pin to metallic. To keep things organized, we can assign these parameters to metallic group. Now we will create another texture sample. Convert it to parameter and name it emissive main. Set default texture to the default texture lineal color. Then while holding number 4 on your keyboard, we will create vector 4, convert it to the parameter and name it emissive color. Set default color to white. Then while holding M, we will make another multiply node. Then while holding 1, we will create another node, convert it to parameter and name it emissive intensity. Then create another multiply node and connect pins. Now we can connect out pin to the emissive color. Let's comment both parts and assign emissive to its own group. Now we just need to make few changes for roughness. We will separate body roughness from metallic body part roughness. Let's set up the logic and then I will explain why we need to make these changes. While holding L, make a click to create a LERP node. Then find roughness main and grab red channel pin to plug it into the B. Then grab this roughness pin and put it as A. Then while holding 1, create a new node, convert it to the parameter and name it metallic roughness. Then create a multiply node, put metallic roughness as B and put metallic main as A. Put multiply end pin as alpha. Then you can take lerp end node and put it as roughness. If you look at this example, currently metallic part is affected by overall body roughness, and it's not shiny at all. If we would like to make it more shiny, we would need to bring down body roughness. If you do that, we can see that our skin also gets shiny, which is something we don't want to. If you connect back pins that we just made, we can adjust roughness for skin and for metallic parts separately. Now open FaceMaster material. We can copy created nodes in the body material and paste them in the FaceMaster material. Since face has extra metallic nodes for makeup, we will create a lerp node. Connect multiply to B, then while holding Ctrl, grab metallic pin and connect it to A. Then connect metallic main as alpha. Grab lerp end pin and put it as metallic. Then while holding Ctrl, we can grab roughness pin and connect it to A for roughness lerp. Then find roughness main and grab red channel pin and connect it as B. Connect lerp end nodes to roughness. Then we just need to grab emissive multiply end pin and connect it to the emissive color. Next, we just need to open face and body materials and replace textures. We will start with the face. Scroll down, find base color. Replace main, CM1, CM2 and CM3 textures. Then find emissive. Enable all 3 emissive settings. Set emissive texture and set emissive intensity to 10. Next, find metallic. And again, enable all 3 settings. Set face metallic texture, then set metallic intensity to 1 and play around with metallic roughness. Then we can go to the normal and replace main, WM1, WM2 and WM3 textures. And lastly, replace roughness texture. Now we will do the same thing for the body. Replace body base color. Then turn on all 3 settings for emissive. Set emissive texture and change intensity to 10. Then enable all 3 settings for metallic. Set body metallic texture and change intensity to 1. Play with the metallic roughness value. Then replace normal main. And lastly, replace body roughness. Now we can assign new materials to our Cyber Viking blueprint. There's one last fix we need to make.
If your character has a texture difference between a head and a body, all you have to do is go to Materials and search for Roughness. By tweaking chest min and max roughness parameters, you can fix difference between both textures. If I set body max roughness to 0.7, there's no more visual difference between both textures. Our Metahuman finally has a truly unique look. We have customized our face and body meshes and applied custom textures. Our character still works with the live link and can use control rig. Excellent! In the final step, I'm gonna just quickly show you how you can make some grooming assets into the Blender. Fortunately, or all these years in MHCreator, we haven't got the tools to actually really customize our hairstyles, make them look different and all that stuff. So with the Blender, with very simple workflow, you can make pretty decent hairstyles. And obviously if you want to make something more advanced, then you would need to look more into the Maya. But for the simple stuff, Blender works fine. And I actually also have that other tutorial. And I actually have a tutorial how you can use the Das hair with your Metahuman. So there are two options, very great, that you can use with your Metahumans.
We will use Blender custom hair particle system without any paid plugin assistance. Here once again, I encourage you to find few reference photos that would fit your project. I will use hairstyle from Assassin's Creed Valhalla as my reference photo. To get started, we need to import our face mesh into our project. Once again, we need to delete the root, so all we have is the mesh. We will start by painting our hairline. Let's switch to the weight paint, then go to Object Data Properties and delete all the vertex groups. Then click the plus sign and add new vertex group. Give it a name, Base Hair. Then just paint your hairline while weight is set to 1. If you need to remove a painted part, just set the weight to the 0 and paint over to remove the detail. Now we can switch back to the object mode and go to particle properties. Click the plus button and add new particle system. Give it a name, Main Hair, and change particle type from the emitter to hair. Scroll down and under the vertex groups, we will select Base Hair. Now the hair is located only in the painted area instead of covering the whole mesh. Then in the children section, set hair as interpolated. Interpolated hair will cover the whole area, generating new parent and children particles. The simple option will generate child particles only next to the parent particles. Change the display and the render amount to 50. Next we will reduce the emission number to something like 200 to have less dense hair. I will set hair length to 6 meters. Since in Blender the character is 100 times bigger than it would be in Unreal Engine, by setting it to 6 meters, it will be 6 centimeters long in Unreal Engine. Now let's switch from the object mode to particle edit. Select comp, make sure deflect emitters, strand length and root position are selected, otherwise hair will go inside mesh. Now we can start to comb hair strands. We can add extra hair by selecting Add. Then, depending on the situation, you can turn on or off the interpolate. Interpolate is off, new hair will be vertical and you will need to comb it manually. If interpolate is on, new hair strand will follow the same comb pattern as other nearby hair strands. My back hair is too short, so I will use length tool to make my back hair longer. I suggest making them a bit longer than needed and then use a cut tool to cut even all extra hair. Next, I will add another particle hair system. I will call it Small Hair. Once again, select Base Hair Vertex Group. Now instead of interpolate, we will set children as simple. We will change kink to curl to change the shape of the hair. We will decrease the emitter number and we will make them way smaller. They need to stick out just a tiny bit to give the hair a messy look. Keep in mind we are also going for as realistic look as possible. It's all in the detail. One last thing the Viking hair is missing is braids. Let's add another particle system and call it Main Braid. I will switch to hair, change number to 1. I will set length to 40 meters, children to simple, and set kink type to braid. Unfortunately, braids are trickiest part of the whole hair particle system, but I thought this is a great example to include for you for this reason. The only thing is, without a plugin assistance, it's hard to make them look just right. For braids, you will need to experiment with the settings on your own, since they will drastically different depending on the braid size you want. These are values I use for my braid. You can use them as a starting point, but you will need to tweak the numbers if you want your braid to be a bit longer or a bit shorter. Once you're happy the way your braid looks, you can switch to the particle edit mode. Click and add, switch count to 1 and make sure interpolate is disabled. Set steps and keys to 8. They work as a bending point, so if your braid is shorter, you will need to decrease the steps and the key count. Now we can plant the braid where it should be and we can remove the other one. Then just going to comb it down. Now we can make smaller braids and add them on the top of the head. The last thing I want to do is to remove some base hair from the parts where we have our cyber gear. Since hair will not grow on the metal, it will also make our cyber parts more visible, since now the hair would fully hide them. Let's go to material properties and create new material. Then let's switch to the shading. Go to add, texture, image texture. Plug color as a base color. Press open and find face base color texture that we exported from the Substance Painter. Then switch back to the layout and switch to the shading. Now we can see where our cyberware is located and we can remove the weight paint from that area. Unfortunately, you will need to switch back and forth between the weight paint and object mode since you are unable to see the texture in the weight paint mode. Then go to the particle edit to shorten the side hair in case they cover your cyberware too much. Once you are happy with the hairstyle, it's time to export it to the Unreal Engine. First, let's go back to the particle properties, and for each particle system we need to make sure that show emitter is disabled in the render section. You can leave it on in the viewport section since it doesn't impact your export. Now let's select head mesh, go to file, export as Alembic. Let's change few things in the option menu. Set end frame to 1 since we don't have any hair animation. Make sure selected objects and visible objects are selected. Then at the bottom, make sure export hair and export particles are selected. Now we can press export. We can open our Unreal Engine project. The first thing we need to do is to enable Alembic Groom import plugin. Let's go to edit plugins, search for hair and enable Alembic Groom importer plugin and restart the engine. Now we can make a hair folder. Find exported hair and drag and drop into the folder. If you have followed all export steps, Grooming import option window should appear. Press import. If you see this window, go through export steps once again. Double check that show emitter is disabled in the render section for all the hair particle systems. Now we need to check our groom asset rotation. Let's drag it into the scene. Our groom asset's rotation doesn't match our character's default rotation. By using the rotation tool, let's rotate here to match our metahuman. I need to rotate groom asset for -90 degrees on x-axis and for 180 degrees on the z-axis. Well, the groom asset looks fine, it's actually mirrored. If we compare left and right side in Unreal Engine with the left and right side in Blender, we can see that we need to invert the sides. The side braid needs to be on the left side, not the right side. It's easy to fix, we just need to change our X scale from 1 to -1. Now the side braid is on the correct side. Write down the rotation numbers, because we will use them to re-import the mesh with the correct rotation. Go back to the grooming asset, right click and select re-import. Now we can set our import values. In my case, X -90, Z 180, X scale is -1. Then press import. If you drag your grooming asset into the scene, it's facing the correct direction. Now let's go to our Cyber Viking blueprint. Go to here and find the new hair grooming asset. As each grooming asset uses the binding asset to know which mesh it needs to be attached to, we need to make one for new grooming asset. Let's right click on the hair and select Create Binding. Now in the target skeletal mesh, find Cyber Viking Face Mesh. Press Create. If your grooming asset rotation is correct, the binding asset will be created and you will not see any errors. If your rotation doesn't match your metahuman, you will get an error that the binding assets could not be built. If you see an error, double check the hair rotation and especially check if your hair is not inverted. Now we can go back to blueprint. Find hair and set our new grooming binding asset. That's it. Now our hair is attached to the head and it works as intended. Now we have a fully customized metahuman.
So we are finally done. So I hope you had fun. I hope you created some amazing metahumans. Don't forget to share them on my Discord channel. I would love to see what you made during this course. It was a long one, it took a lot of time to make, edit, and I really hope you learned a lot. So if you enjoyed this free course, then I have my Patreon and my YouTube memberships up with 2 simple plans to support the channel.
or you can just like and subscribe and comment down below what kind of other Metahuman related content you would like to see. So I hope you got fun, because I definitely did editing this video, and see you in the next one. Bye!